Hi everyone. Today we are going to talk about the next building block which Satoshi used in order to define a Bitcoin network. So the next building block is hash. So for example, let's say I want to send input data message to someone, and hash is nothing but you can consider it as a fingerprints. So whatever is the size of data which I want to transfer, if I pass it through a hash function, it should give me a fixed length output, which is kind of a fingerprint for the data which I want to send. This is also known as digest or hash output. So this hash function should have certain properties. For example, it should be unique and deterministic. So by this we mean that if I'm passing the same data multiple times on the same hash function, the digest which I'm getting out of it should be unique. It shouldn't happen that one time I'm getting some value, another time I'm getting another value. Rather, it should be same across all the runs. It should be one way. By one way, I mean that let's say I pass some data through hash function and got some output. In no case, I should be able to decipher the input from the output, right? It's always unidirectional. Output length has to be fixed and it has to be collision free. So by collision free, we mean that the output or the digest of any hash function should have unique values for different inputs, right? Otherwise, it doesn't make sense at all. So let us see one example. So I've again landed up to this Enders website, and this is the demo for hash function. So Bitcoin uses SHA-256 as hashing algorithm. Why 256? 256 means that this is going to output a string which is 256 in bits, and which essentially mean that 64 characters of data. So whatever data I put, your hash function will change. So it doesn't matter what is the length of your string, your output is always going to be of 64 characters. And even if you change a single bit of it, let's say for blockchain, this is the hash output. But let's say if I go ahead and change the case of B, my output should completely change. So this hash function gives me all the four properties which we wanted, which is being unique, being unidirectional, having fixed length, and almost collision free, right? So the next question which we should ask is whether the function which we are considering is actually collision free or not. So it turns out that it is not entirely collision free, but it's almost collision free. So by that I mean that if you see the total number of possible combinations which it can take is 64 to the power 16. In hacks, there are 60 characters, which are a combination of alphabets and numerics. So the probability of getting a collision is as low as 1.26 e raised to the power minus 29, right? So it's almost zero, right? So there is no known collisions which have been found so far. And if you see, like to generate a hash, it changes with a single character. So even if you want to fool the system to get the exact same hash, it's really not worth it, right? You have to try so many combinations. So why this hash pointer or like the hash was used by Satoshi? So in a way, it is used to bring in immutability in the blockchain. So remember, we discussed that blockchain is nothing but the append-only timestamp ledger. So in order to achieve that append-only component of blockchain, hash pointers are used. So let's say I have a block which contains some data, and let's say hash of this data is 5ADR and block number is 123. So what we typically do when I'm going to add the next block, okay, so this hash becomes part of the data for the next block, and the hash which we are getting 52ab is on the combination of data 1 and 5 ADR. So in a way, both the blocks are linked by hash of the previous block, and this is known as hash pointer. Okay, so this block will have reference to the previous block, so on and so forth. So if you see, like, this block has previous hash, called zeros in this case, but similarly the hash for this block is this one, and this block number one is linked to block number two by a hash pointer, which is nothing but the hash of previous block is kept in previous hash key for this block. What we essentially mean is, let's say if I change data in the first block, the entire blockchain gets invalidated, right? So if somebody wants to go ahead and fool the system or want to change the blockchain, he has to update all the blocks in the blockchain, right? So he has to put this hash in the previous hash of the next block, and so on and so forth. So for the second building block, hash and hash pointers. To repeat, hash is nothing but just a fingerprint of the data, and hash pointer is used to bring in immutability in the blockchain. That if I want to change some data in the previous block, all the forward blocks will get invalidated. And if somebody wants to purposefully change the entire blockchain, then he has to go ahead and change the hash values in all the blocks. Really not further. Thank you. We'll see next blocks in the upcoming videos.